When we look at the biggest mysteries in modern physics, we treat them like isolated puzzles. We build entirely separate frameworks to solve them. Cosmologists peer into the deep universe and find galaxies spinning too fast. To make the math work, they assume there must be vast clouds of invisible particles, dark matter, that we simply haven't detected yet. Meanwhile, physicists studying extreme gravity look at black holes and run into a completely different problem. They assume information falling in is trapped in a permanent storage box, leading to decades of debate over how it eventually escapes. We assume we are missing physical pieces of the universe, but the Golden Physics Project proposes an alternative. We aren't missing parts. We are missing a single geometric rule that governs all of them. This rule is called the shadow framework. It suggests that one specific mathematical reflection resolves these disconnected mysteries. In mathematics, this is an involution, or a self-dual interface. It is a perfect mathematical mirror. Data approaching this boundary perfectly inverts on the opposite side. This boundary acts as a critical point, forcing opposing states into a flawless equilibrium. If this geometric reflection is the baseline rule of reality, we should see it operating at the edge of space, at the beginning of time, and deep inside a black hole. Let's apply this mathematical mirror to the beginning of the universe. We typically assume the Big Bang was a single point that emerged from nothing. In the shadow framework, the Big Bang is a T-boundary, a mirror interface in time. We live on the forward time side, surrounded by standard matter. To balance the geometry, a perfectly reflected antimatter universe exists on the conjugate side. The universe operates as a two-sided geometric structure, present from the start. We apply this exact same rule to the largest scales of the cosmos, looking out toward the celestial boundary of the universe. Because the universe obeys this geometric symmetry, every piece of normal matter projects a shadow conjugate onto that boundary. This shadow conjugate couples to our reality exclusively through gravity. It pulls on galaxies and shapes the cosmos, but possesses no physical substance. Dark matter remains elusive because it is a gravitational footprint, the geometric shadow cast by ordinary matter across the celestial boundary. This realization changes how we define the hunt for missing mass. Now, let's take this mirror and hold it up to the most extreme gravity environments in nature, black holes. The event horizon functions as a shadow boundary rather than a physical storage box. When a particle falls toward this horizon, extreme conditions force it to decompose into two shadow conjugate halves. They meet at the boundary and instantly annihilate into branch-balanced photons. One escapes into our universe, its mirror heading into the conjugate universe. We don't see this instantaneous flash from the outside. The photon released into our universe has to climb out of such a deep gravitational well that it is delayed and stretched. This is the redshift illusion. The slow release of information is a gravitational illusion. At the shadow interface, matter converts to light instantly, leaving Hawking radiation as the stretched, redshifted signature of that conversion. Dark matter, the black hole information paradox, and the nature of the Big Bang are exact expressions of the same mathematical reflection. This chart shows the dark energy equation of state derived from the self-dual Haar measure on the Grassmannian. By starting with these geometric invariants, the results, like this phantom crossing point, emerge as fixed mathematical consequences, leaving no room for free parameters. Nature operates using one foundational rule, repeating it flawlessly across every scale of reality. This means we can stop trying to invent new physical particles, unknown forces, or hidden storage boxes in spacetime to make our observations make sense. The answers emerge when we recognize the two-sided symmetry of existing systems, rather than adding new clutter to the universe. From the edge of a black hole to the dawn of time, the universe is an elegant, unbroken chain of reflections.